My dear students, good morning. Now we will discuss about reducing agent and oxidizing agent. So previously we discussed about balancing of redox reaction by ion electron method. So now this is the most important thing. In many chapters we have this main reducing agent and oxidizing agent in electrochemistry chapter and many chapters like that. Okay, so very important. What is the reducing agent? You must have a clear idea. So before that you must know what is a reduction. What is reduction? Everybody knows. Reduction means gaining of electrons, right? Reduction means what? Gaining of electrons, right? Gaining of electrons. In terms of electrons you can say. Gaining of electrons is called reduction. Okay? Or else we said in another way, during reduction what happened? Reduce or decrease in oxidation number or oxidation state. That is called reduction. The process in which gain of electrons takes place, okay, or reduce in oxidation number happen for a particular atom in a particular chemical reaction, then that process is called reduction process. So which atom undergone reduction means the particular atom for whom oxidation number reduced we have to check. Got it clearly? So that is reduction. Next is oxidation. What is meant by oxidation? This also everybody knows. Here reduction means gain of electrons, taking reduction. Okay. So here oxidation means loss of electrons. Okay. So here what happens? Increase in oxidation number. That is what we call oxidation. So reduction means gain of electron and reduce in oxidation state. Okay, so here oxidation means loss of electron or else increase in oxidation number. How to identify reduction happened or oxidation happened? That particular atom won't say, hi, I undergone oxidation, I undergone reduction, like that. So we have to observe, okay, here in reactants, this particular atom has +5. In products, that particular atom has oxidation state +2. Okay, oxidation number reduced for that particular atom, so that undergone reduction, like that. So this everything known now. So I want what is reducing agent. Reducing agent is our next concept. Next thing. Reducing agent means agent to reduce others. What agent will do? Agent will help others. Okay, here agent means some particular atom X is reducing others. This X is a agent. What agent? It is a reducing agent. So what is the duty of this Mr. X? Okay, suppose this X is Girisar only. So Girisar is a reducing agent. So what he have to do? He have to reduce others. Agent will do for others or not? Tell me. Okay. So here also reducing agent means, now I will give you the most important definition. Okay. So understood? X is the reducing agent means itself reducing others. And that particular X is undergoing oxidation. Understanding? So here X oxidizing itself and reducing others. That's happening mainly. So what is the definition? So the particular reducing agent means we can write like this, which itself undergo oxidation, which itself undergo oxidation and reduces other agent. Agent will do reverse work or not? Tell me. Yes. So what is the reducing agent? This X is the reducing agent means it reduces others. So don't think it will undergo reduction. It will undergo oxidation. This is the most important thing. So what is the reducing agent means? The particular agent or atom or a particular species which itself undergoing oxidation and reduces others. Simple. That is a reducing agent. It can be molecule, it can be ion, means like a species, we can say simply cation, anion, like that. Getting what I am saying? So very very important. It can be cation, it can be anion, it can be a molecule, it can be atom. So that way we will say what is reducing agent. Simply the species, those species I have read, the species which itself undergo oxidation and reduces others. That is what we call reducing agent. So now from that we can say what is oxidizing agent. Oxidizing agent. So it's very clear now. Reducing agent means itself undergoing oxidation. So ulta we have to think, okay, oxidizing agent, so itself undergo reduction. Reducing agent, okay, itself undergo oxidation. Like that we have to think first of all in your brain. Okay, which of the following is reducing agent? If they ask, first thing, okay, in that who is undergoing oxidation? Simple. How to identify oxidation? In which increase in oxidation state happened. So loss of electron or gain of electron identification is difficult, but calculation of oxidation number everybody knows. So particular atom from reactants to products oxidation state increased or decreased, that knowing is very simple. Okay, that thing we can easily understand. So that if any atom its oxidation state increased, then you can say that particular atom or a species can be undergoing oxidation means can be a reducing agent. Okay, so oxidizing agent means reverse. You can write now definition. What is the definition for this? Very simple. So which the species you can write, the species which itself undergo reduction, okay, and oxidize others, you can say this is oxidizing agent. So which itself undergo reduction means some others it is oxidizing. Very simple. Oxidizing others. Very clear. So please have a note what is reduction and what is oxidation, and what is reducing agent and what is oxidizing agent. Simple thing. How to identify whether a particular species is undergoing oxidation or reduction means just from oxidation number. So how we can come to know that oxidation number means I told you the process and procedure how to calculate oxidation number I was given already. So you can use that process. By knowing that oxidation number, we can say whether the particular species is undergoing oxidation or reduction, so that you can say that acting as oxidizing agent or reducing agent. See, let's have some examples, sir, please. So please write down, it's a reduction and it is oxidation and reducing agent and oxidizing agent. Pause the video, write down. Okay. So next one is some examples we have to see about reducing agent and oxidizing agent. Okay, sir. So let's have a look about some examples here. See here, I will give you Zn plus copper sulfate converts to ZnSO4 and Mr. Copper. Okay, this is copper. So, who undergone oxidation? Who undergone reduction? The same you can write like this: Zn plus copper plus 2 and here Zn plus 2 plus copper. Okay. So here, why you written sir means sulfate minus 2, no? So copper is plus 2. So here sulfate is minus 2. So zinc is plus 2. Like that I written. Hope you understood. So now elemental state means oxidation state 0. I told you already. Here copper 2 plus is oxidation state is plus 2. Here Zn2 plus means here oxidation state is plus 2 and here copper means 0. So zinc oxidation state, if you observe, it's converted from 0 to plus 2. Zinc oxidation state changed from 0 to plus 2. So oxidation number, what happened? Oxidation number or oxidation state increased. So it's a oxidation process. Okay, it's very clear now. So now this one, what happened? Copper plus 2 is converted to 0. Plus 2 converted to 0 means what happened? Oxidation number decreased. So this process is called reduction. So this is oxidation, that is a reduction. So very simple, Zn undergone oxidation. What this is? Oxidation. Zn undergone oxidation. Correct. And copper plus 2. Copper plus 2 undergone reduction. Undergone reduction. So clear? So zinc undergone oxidation and copper 2 plus undergone reduction. Clear? So zinc undergone oxidation means it is reducing agent. Ulta, you have to think very clear. How you said sir without confusion means I know already, that's why I said. So zinc oxidation state increased. So zinc undergone oxidation. Undergone oxidation means itself, undergoing oxidation means that zinc acting as reducing agent. How I said understood? Because zinc oxidation state increased. So zinc undergone oxidation. But sir, why oxidation I said? Because increase in oxidation state happened. So oxidation. So zinc is a reducing agent. So copper 2 plus reduction, because copper 2 plus changed from copper plus 2 to copper. Okay, so decrease in oxidation state happened. So undergone reduction. Undergone reduction means oxidizing agent. Oxidizing agent, like this we can say. Okay, reverse reaction won't happen. Why? I'll tell you. Okay, so this reaction happened. So in this zinc undergone oxidation, copper 2 plus undergone reduction. So we can say zinc is a reducing agent and copper 2 plus is a oxidizing agent. Okay, so I'll give you one more example like KMnO4, okay, and FeSO4 and converted to Fe2SO4 thrice. Fe2SO4 thrice. Sorry. Shit. And plus manganese plus 2. This happens in presence of acid H plus. So here what we have to see, KMnO4 and FeSO4 as converted to Fe2SO4 thrice and Mn plus 2. For this balancing is not required for me, because for oxidation state I told you just per molecule only we will consider. Okay, so here manganese oxidation state is very important for me. X plus, potassium is a plus 1 and 4 into minus 2 is equal to 0. That means X equal to plus 7. And here manganese is a plus 2. Got it? FeSO4, sulfate minus 2, therefore Fe is plus 2. Here iron will get plus 3. You can check 2x plus 3 into minus 2 is equal to 0. 2x equal to plus 6, then x equal to plus 3. So very clear what happened. Here iron is plus 2. Here Fe2SO4 thrice, iron is plus 3. So what are the conversions happened? I'll write here. Have a look once again, please. This example 2. In this, KMnO4 act as my question. Okay, or they will give reaction like this. And which of the following is the oxidizing agent, or which of the following is the reducing agent? Like that question they will give. So KMnO4 converted to Mn plus 2. You can see, sir, whose oxidation state will change? Sir, where is potassium? Don't ask me. But potassium will convert as K2SO4 here in presence of acid. Like H2SO4 we use. Then K2SO4 like that. K plus, oxygen is minus 2, no change. Then whose oxidation state here changed clearly? You can see manganese oxidation state changed from plus 7 to plus 2, and iron oxidation state changed from plus 2 to plus 3. Other than manganese and iron, no other atom has a different oxidation state. In remaining, means in reactants and products, potassium, oxygen, sulfur all have a similar oxidation state, because here sulfate, here also sulfate. The sulfur oxidation state won't change. Here oxide form, here oxide form. Oxygen oxidation state won't change. Potassium, I told you already, alkali metals always exhibit plus 1. So no confusion there. Certainly whose oxidation state changed, I'll write there, please have a look at this. Okay, have a screenshot. So what happened here? KMnO4 is converted to Mn plus 2, and Fe2 plus is converted to Fe3 plus. Now you only tell me, here manganese plus 7 converted to manganese plus 2. Manganese plus 7 converted to manganese plus 2. So what happened? Its oxidation state reduced or not? So decrease in oxidation state. Decrease in oxidation state means it undergone reduction. So KMnO4 is an oxidizing agent, because KMnO4 oxidation state, in that not KMnO4, sorry, in KMnO4 manganese oxidation state is plus 7, and in manganese plus 2 oxidation state is plus 2. So here plus 7 converted to plus 2. So KMnO4 undergone what? Reduction. This is a reduction or not, tell me? And Fe2 plus converted to Fe3 plus 2 converted to plus 3. That means oxidation state, what happened? Increase in oxidation state. Increase in oxidation state means, so Fe2 plus is undergone oxidation. So you can say that KMnO4 is oxidizing agent. Why KMnO4 is oxidizing agent? Understood? Because manganese oxidation state changed from plus 7 to plus 2. So manganese oxidation state reduced. So manganese undergone reduction. Therefore KMnO4 undergone reduction means KMnO4 is a oxidizing agent because undergone reduction. Same story, FeSO4. Actually iron why I considered means iron oxidation state changed. That's why. Here manganese why I considered means manganese oxidation state changed. So FeSO4 converted to Fe2SO4 thrice. So FeSO4 is reducing agent. Reducing agent. What is the reason behind it? Because FeSO4 is FeSO4 in that Fe oxidation state is plus 2, but that converts to ferric sulfate, Fe2SO4 thrice. Here oxidation state is plus 3. So iron oxidation state increased. So iron undergone oxidation. Correct. So FeSO4 is reducing agent because it undergone oxidation. So FeSO4 is reducing agent. Hope you understood. So please have a note all these things. So for this second example, this is the continuation. So KMnO4, very simple, actually no need to write. So manganese oxidation state reduced. So manganese oxidation state reduced means it's undergone reduction. It's undergone reduction means oxidizing agent. How simple, you have no need to write all these things. Clear? So undergone reduction means oxidizing agent. Very simple. Okay. So you have no need to confuse. So for that only thing you have to calculate oxidation states without doing any mistake. Okay. Properly if you can calculate oxidation state, it's very simple. So please have a look. It's very important. Okay. Next is the most important thing is how to identify. Two examples, okay, we understood. So 10 examples, 20 examples is not matter. How to identify whether reduction happened or oxidation happened. If reduction happened in a particular species, that is oxidizing agent. If any species in that atom undergone oxidation, that is reducing agent. This is very clear. So one more most important thing, how to identify whether a particular species can undergo oxidation, can undergo reduction, cannot undergo oxidation or cannot undergo reduction, how to say. For that, I told you previously, for a particular atom, what is the general oxidation state? Up to 4A group elements, up to 4A is plus group number. Do you know this? Correct? And this is number one. And number two, what is the general oxidation state of atom from 5th A to 8th A? Okay, general oxidation state of whom? Of atom from 5th A to 8th A. General oxidation state of atom from up to 4A, group number, is group number -8. Correct? Okay. So one more, as going down. I told you this, as going down in group, in any group from 3rd A to 8th A. I told you this. From 3rd A to 8th A, in any group, you consider 3rd A group or you consider 8th group, as going down, one more oxidation state exists, that is group number oxidation state exists. Group number oxidation state exists. Of course, group number -2 also exists. One more, group number -2 oxidation state also exists, but forget about this right now. Okay. So, as going down from 3rd A to 8th A, every element is exhibiting group number oxidation state. So, if you remember these two, this is the general oxidation state and this is as going down what happened. This is the third one, as going down what happened. As going down, group number oxidation state exists, and group number oxidation state is the maximum oxidation state of any particular atom. Any particular atom. This is a very, very important thing. And group number -8 is the minimum oxidation state. Forget about this. This is the group number oxidation state. And as going down from 3rd A and 4th A. 1A and 2A I already told you. They always exhibit +1. 2A always exhibit +2, I told you. 1A always +1, 2A always +2. But here up to 4A means what is the meaning? 1A, 2A, 3rd A, 4A. This 1A, 2A always oxidation state. 1A means always +1. 2A means always +2. These two forget. 3rd A and 4A, they exhibit group number as well as group number -2 as going down. Okay. So everything here only we have. The second and third. What I said understood? 1A and 2A no change and no more discussions. 1A always +1, 2A always +2, and 3rd A and 4A they exhibit two oxidation state. One is a group number, and as going down group number -2, and as going down group number -2 oxidation state is more stable due to inert pair effect. I told you in previous. And now our discussion about second point and third point. First point, hope so you understood. Okay. So minimum oxidation state of any atom from 50A to 80A atom. For any 50A to 80A atom, group number -8 is the minimum oxidation state and group number is the maximum oxidation state. For whom? For those elements which are present in any group of 50A to 80A. Suppose phosphorus minimum oxidation state is what? And maximum oxidation state is what? If you see, phosphorus which group? It's a 50A group, right? So phosphorus minimum means least oxidation state, that is. So minimum oxidation state is group number -8, that is 5 minus 8, that is -3, remember. So -3 is the minimum oxidation state. So can -4 possible? No, not at all possible. So minimum oxidation state is -3 and maximum oxidation state is +5, because maximum oxidation state is plus group number. I said plus group number means what is the meaning? +5. So very clear. So phosphorus minimum oxidation state is -3 and phosphorus maximum oxidation state is +5. So if you see like this now, phosphorus, for the two examples I will take, the pH3 and one is some H3PO4. Okay, here phosphorus oxidation state, if you see, X plus 3 into plus 1 is equal to 0. That implies X equal to -3. Here phosphorus, if you see, X plus 3 into plus 1 plus 4 into -2 is equal to 0. That implies X equal to +5. So -3. So X -3 means here minimum oxidation state or not? This is the minimum oxidation state. Listen carefully. Please everyone concentrate here. So minimum oxidation state, if there, it cannot undergo reduction. So please explain. Why cannot undergo reduction? Because already minimum oxidation state is there. What is the minimum oxidation state? -3. During reduction, what I told you, oxidation state must reduce. So during reduction, this oxidation state must reduce from -3 to some -4, -5, -6, like that must happen. But -3 only least. So already it is having a minimum oxidation state, so cannot undergo reduction. This pH3 cannot undergo reduction. Hope you understood. Because what is the reason? Minimum oxidation state means further decrease in oxidation state not possible. Hope you understood everyone. So I repeat, in pH3 phosphorus oxidation state is -3. -3 means that is already minimum oxidation state. Phosphorus minimum oxidation state is already -3. So in pH3 phosphorus is -3. So minimum oxidation state it is having. So further decrease in oxidation state not possible. So cannot undergo reduction. Why, sir, cannot undergo reduction means? I am telling you very clearly, it cannot undergo reduction because it cannot decrease its oxidation state. It cannot reduce its oxidation state because it is already having minimum oxidation state. So very simple, minimum means very less. Already minimum means how it can reduce. Very simple, I have a minimum amount of money, 100 rupees I have. That much only I have for today. For with 100 rupees I have to take breakfast, lunch and dinner. If somebody came and asked me, that's a minimum amount, and give 10 rupees means I cannot. As a normal person I am telling you. Practically if you think we cannot reduce. No sir, I'm very good enough, I will donate and I won't take dinner, no problem. Don't say like that. Generally I am telling. So 100 rupees I have. So 100 rupees is needed for me, that is a minimum amount. So how I can reduce that amount? 100 is a minimum. Than 100 I cannot reduce. Than 100 I cannot take less, like 70, 80 rupees I cannot have. So 100 is a minimum. So I cannot undergo reduction. Undergo means, understanding everyone? So reduction not possible further. So further reduction not possible means, cannot undergo reduction means, what is meaning? Cannot be oxidizing agent. Cannot be oxidizing agent. Who cannot be oxidizing agent? Simple thing, can I use it? So which of the following cannot be oxidizing agent means, first in your mind one thing should strike. Okay, in which of the following four options the particular central atom has minimum oxidation state? Because whose oxidation state always changes? Central atom. Who is the central atom? I told you already, less electronegative atom is the central atom. Okay, my question is, which of the following cannot be oxidizing agent? Okay, in my mind first question came, okay, whose oxidation state? Whose oxidation state is minimum in among all four options in central atoms? You have to see. Okay, you identified in some second option the central atom has a minimum oxidation state. So it cannot undergo reduction further, so it cannot be oxidizing agent. Got it clearly? So how to identify minimum oxidation state and maximum oxidation state? That's why I told you here. Group number -8 is the minimum oxidation state and group number is the maximum oxidation state. Hope you understood this example. So pH3 cannot be a oxidizing agent. So very simple logic and simple thing you have to remember. Who have the central atom which have a minimum oxidation state, which is called group number -8, that cannot undergo reduction further, that cannot be an oxidizing agent. Clear? Like that. In this example, H3PO4, it is already having the maximum oxidation state. Maximum oxidation state is having, sorry. It is having maximum oxidation state. Maximum oxidation state means cannot undergo oxidation, because if it undergo an oxidation it have to increase its oxidation state, but already having maximum oxidation state, so that this H3PO4 cannot be reducing agent. Why cannot be reducing agent? Because it is already having maximum oxidation state, so that if I have maximum oxidation state, that cannot undergo oxidation further, so that cannot be a reducing agent. So have a look and please have a screenshot. This is very important. From this you can say who is oxidizing agent and who is reducing agent. One more way is there, which is undergoing reduction, which is undergoing oxidation, which is reducing agent and which is oxidizing agent. We will come to know from SRP values, standard reduction potential values. Okay, the concept you will have in electrochemistry, but SRP values I will explain here only. Okay, explain means some values I will give, and from those values we can come to know who is undergoing oxidation and who is undergoing reduction, so that who can be oxidizing agent, who can be reducing agent, we can understand. So finally, have a look. These are very important. So final, have a screenshot please. Okay. So finally, what I said, who have a minimum oxidation state. What is the minimum oxidation state? Group number -8. What is the maximum oxidation state? Group number for a particular atom. From 5th year to 8th year. 3rd year and 4th year also group number only maximum. Okay. So no need to worry, sir, what about 3rd year and 4th year? Why I am not talking about 1 year and 2 year? Because 1 year always +1, 2 year always +2. So what I said, if atom with minimum oxidation state, atom with minimum oxidation state. Cannot undergo further reduction. What I written is correct or not? Correct. Because already minimum is there, it cannot reduce its oxidation state. So cannot undergo further reduction means cannot be cannot undergo further reduction means cannot be oxidizing agent. Why cannot be oxidizing agent? Because cannot undergo further reduction. So atom means which atoms are? Central atoms are here. Atom with the minimum oxidation state. Okay, central atoms are here. In a molecule. Central atom in a molecule. I cannot write all those. Simple short way to remember. Same. Atom with maximum oxidation state cannot undergo oxidation further. Who have a maximum oxidation state, already maximum, because it cannot undergo oxidation is what is the reason? During oxidation state during oxidation state must increase, but already maximum is there. So cannot undergo oxidation, therefore cannot be reducing agent. Cannot be reducing agent. Okay, hope you understood. Practice all this, and these two are very, very important for us. And for today, okay, enough. And next we will discuss few more examples. Then next we will enter into new chapter.